Hey Mariana, we're going to work on examples and rules for the assignment Powers of Products and Quotients Integer Exponents. Okay, we're going to get right to it since I don't know how long this video will be able to last. So we're going to start with some rules. These are general exponent rules. The first one that you're going to see probably in each problem is when you have a negative exponent. So if you got a to the negative 4, okay? Generally, we don't like to leave problems like this. Even though this might be your answer, we want to change it so it has a positive exponent. And that's just a simple flipping over the fraction. So if we have a to the negative 4, we can rewrite this as a to the negative 4, but it's on the bottom of a fraction. So we put 1 on the top because that's kind of like a placeholder because we have nothing else on the top. And the bottom is going to be a to the positive 4. So we've got rid of our negative exponent by flipping it to the bottom of the fraction and making that exponent positive. Let's do another example for that. This is our main rule though. So if we had multiple variables, let's see what would happen. A to the negative 4, b to the 5th, all divided by c to the 2nd power, and d to the negative 1. So we got 4 variables here. They're all multiplied to each other. So again, if this was our answer, we would want to make sure that we don't have any negative exponents. So we see a couple of problems here. We see a to the negative 4 is a problem. So to fix that, we use this rule. We're going to flip it to the bottom of the fraction. So we're going to move this guy down here, and it's going to be a to the positive 4. So when we flip it to the other side of the fraction, exponent becomes positive, and that will go away. It's no longer on the top, it's on the bottom. So we fixed a, but we still have d to the negative 1 we need to fix. We don't like negative exponents, but it's already on the bottom. How are we going to fix that to a positive 1? We're actually just going to move it to the top. So it doesn't matter whether it's going to the top or the bottom. The main thing is that it needs to switch sides. So this guy is going to go to the top, and it's going to be d to the positive 1. And this guy will go away. So our answer, what's left on the top, is b to the 5th times d to the 1. What's left on the bottom, a to the 4th times c squared. Awesome. Okay, we're going to do one more, just make sure we get it. So let's do w to the 4th, x to the negative 2nd, and y to the 3rd, all over z to the negative 7. Okay, again, we have a couple negative exponents we want to get rid of. So the first one we can get rid of is the x to the negative 2. Hopefully you kind of got the idea by now. We need to move this guy to the bottom of the fraction. So we're going to move it. It's going to be x to the positive 2. That goes away. And then we need to change this z to the negative 7 to be a positive 7 by flipping it to the other side of the fraction. We get z to the positive 7. And then this goes away. So our new answer, what's left on the top, is w to the 4th. This went away. Now we have y to the 3rd. And this is our new addition here, z to the 7th. All over, now z to the negative 7 went to the top, but what's left is x squared on the bottom. So that's our answer. Cool dealio. All right, we've got one other main rule here, but it can be applied in different ways. So this is kind of our first big rule that probably will show up in a lot of your problems. The other one is when you have an exponent on top of an exponent. So you have 8 to the 3rd here, but then they put an exponent on top of that, like that. Now what does that really mean in mathematics? Well, squared just means multiply this guy by itself 2 times. So this really means a to the 3rd times a to the 3rd. 2 times. That's that 2 represents 2 times. Okay, but then how many a's do we actually have? How many a's do we actually have? Well, this is 3 a's, so a times a times a. This is another 3 a's, a times a times a. How many A's is that actually? 6 A's. So what did we do here with this 3 and the 2 as a shortcut instead of like writing out a bunch of A's? What did we do here? Well, we multiplied. We multiplied 3 and 2 together. So the rule is when you have an exponent on top of another exponent, you're going to multiply those guys together to get your final answer, e to the 6th. Okay, let's do another example. So our main rule here is when you have an exponent on top of an exponent, you multiply. All right, another example, b to the 4th, and then on top of that, raised to the 6th. So we're going to multiply these together. Multiply. So really, we've got b to the 6 times 4 is 24. That's our answer. We actually have 24 b's in this little expression here. All right, let's do another example and make sure we got it. Even if we have negative exponents, that's okay. So we're going to do the same thing, multiply because it's an exponent on top of an exponent. So this is really c to the negative 10. Now, we don't want to leave our answer like that. We want to utilize this rule that we learned over here. If we want to get rid of a negative exponent, we got to flip it to the other side of the fraction. So really, this is in a fraction. We got to move this guy to the bottom. It's going to be c to the positive 10, and this guy goes away. So this is c to the 10. But what goes up here? There's nothing up here. A placeholder for multiplication is always 1. So we have 1 over c to the 10. Bam. Okay. So these are the main rules. But this kind of expands a little more if you had more variables in the parentheses. So let's go over some of those possibilities here. So if we had multiple variables inside the parenthesis, and then we had an exponent on the outside, we still utilize this rule of when an exponent on top of each other, you multiply. But for this one, we actually have to multiply to both variables. Okay, so this one we just multiplied two numbers together. Here we're going to multiply 2 and 4 together, and 2 and 3. Okay, this only works because a and b are multiplied together. If they were added, you would actually have to expand this in that FOIL, which would take too long. But since they're multiplied, that's really nice. We just have to kind of distribute this 2 and multiply it to the 3 and the 4. So that's really nice. So this is going to look like is a, 3 times 2 is 6, and then b, 4 times 2 is 8. That's it. So again, we're utilizing this rule, but if there's more than one variable inside the exponent, parenthesis, and they're multiplied together, then you can kind of just distribute this 2 to both of the variables. It's really nice. Okay, let's do another example. So this is kind of another one of our rules. Another example for this, x to the 7, y to the negative 2, raised to the 3rd power. So again, we just distribute that 3 to both of these exponents as long as these two variables are multiplied. That's the important thing. So this becomes x to the 7 times 3 is 21. Then negative 2 times 3 is negative 6. But again, we don't want to leave our answer with a negative exponent. We want to get rid of that negative exponent. So we take this guy. We want to move it to the other side of the fraction because that's what gets rid of a negative exponent. We're utilizing this rule over here. So we just move it to the other side. It's going to be y to the positive 6. And that goes away. So your final answer is x to the 21 over y to the 6th. All positive exponents. Sweet. Okay, let's do one more addition to this rule. So you're pretty good probably by now as multiplying those exponents together if there's multiple variables in here. But another possibility is if these variables are divided instead of multiplied. So let's look at a possibility like that. So if you had a to the third over b to the fourth, that's a 3, in case you were wondering. And this is all raised to the second power. Okay, same thing applies. I know they're not being multiplied, but divided is kind of similar to multiplication. Just like multiplying by 0.5 is the same thing as dividing by 2. So they're very similar. So we can do the same thing. We can distribute this 2 and multiply it to each of the exponents, to each of the variables here. Okay, so this is going to become a to the 3 times 2 is 6 over b, and then 4 times 2 is 8. Okay, so we do the same thing we do here. Multiply it to each of the variables inside the parenthesis. So that's kind of like our third rule in this kind of sequence here. All right, let's do an example. Get our feet wet here. X to the 7th over z to the negative 3 raised to the 4th. Okay, again, we distribute that 4 to each of these exponents. So we get x to the 7 times 4 is 28 over z, and then negative 3 times 4 is negative 12. Okay, so that's awesome, but we don't like our negative exponents. They always follow us. We gotta get rid of them. Okay, so we gotta take this z to the negative 12. We gotta move it. To get rid of this negative, we have to move it to the other side of the fraction. So we've got a positive z to the positive 12 up here. It's multiplied. And this goes away. So we're left with, on the top, we've got x to the 28th times z to the positive 12. There's nothing on the bottom, so we could just leave it like that. Or if you feel more comfortable, you could put divide over 1. But dividing by 1, that keeps it the same. So we don't really actually need the 1 on the bottom, but we do need it on the top when we have nothing on the top, like up here. We did need to put a placeholder on the top. But if the 1 is just on the bottom, we don't need it. So we can just leave it like that. Okay. All right, so we've kind of gone all over the rules. I'm going to take some examples from Khan Academy. We'll do 4 examples that kind of mix all of those together, make sure we understand it. So hope you're doing well in quarantine. I know I'm kind of going stir crazy, trying to find new hobbies. It's not going well. Okay, examples. So we're going to start with the first example here from Khan Academy. We've got 3 to the 6th over y to the negative 5th, and all raised to the second power. Now, we just did an example like this, so that's pretty awesome. If you want us to pause the video and try it yourself, that'd be cool too. So, when we have exponents on top of each other, we multiply. We just gotta make sure we multiply to all of the exponents here. So we've got then on the top 3 to the 6 times 2 is 12. And on the bottom, we've got negative 5 to the second. Negative 5 times 2, which is negative 10. Awesome. Okay, but we don't like that negative 10. So to get that exponent to be positive, we have to flip it to the other side of the fraction. So we've got y to the positive 10. And this goes away. So we're just left with 3 to the 12th times y to the 10th. Ooh. You could put a 1 under here, but you don't need it. You don't need 1 on the bottom. So you're done. Cool. All right, second example from Khan Academy. We've got it just a multiplication, so we got 3, oh, wrong color. 3 to the 3rd times 6 to the 6th, wow, raised to the negative 3. Okay. All right. Again, you can pause the video, see if you can do it on your own. but we've got an exponent on top of two exponents, but there's multiple stuff inside the parentheses, so we have to make sure we distribute that 3 to both exponents. So 3 raised to the 3 times -3, that'd be -9. And then 6 raised to the 6 times -3, it's -18. Awesome. But they're both negative. Oh gosh. So we have to flip both of them over the fraction. Just gotta make a little fraction bar for yourself. Take this whole guy, we flip it to the bottom, so we got 3 to the +9, and that goes away. Take this whole thing, we gotta move it to the bottom, 6 to the +18, that goes away. So now we're left with, there's nothing on the bottom, we have to put a placeholder 1. And then on the bottom, we've got 3 to the 9th, and then 6 to the 18th. And they're technically multiplied together. Technically, you could put this in your calculator and get a huge number on the bottom, but Khan Academy's not asking for that. It's just asking for positive exponents, so you are done. All right, 2 more examples. All right, these are kind of similar, but more examples is never bad. All right, we got 2 to the -4th times z to the -3rd raised to the 5th. I did the wrong color again. Oh gosh. All right, again, pause the video, see if you can do it on your own. We got exponents on top of each other, so we just distribute that exponent. So we're left with 2 to the -20, because we did -4 times 5, times z, and then -3 times 5 is -15. Okay, again, we're stuck with 2 negative exponents. We gotta flip those to the bottom of the fraction. So we take this guy, flip it, becomes 2 to the +20, that goes away. Take z to the -15, you flip it, and it magically becomes z to the +15, that goes away. And then you're left with nothing on the top. So you have to have a placeholder 1 over 2 to the 20 times z to the 15. Bam. Okay, my video is becoming very long. I really hope it uploads. Let's see. Number 4. If not, I'll just have to snip it into tiny bits. We'll see how that goes. Okay, I'll use the right colors this time. 3 to the -6, last problem. 7 to the -3rd. All raised to the 5th. Okay, same quotient type of problem. You've got to multiply that exponent to each of the exponents inside. So on the top, you've got 3 to the -6 times 5, it's -30, over 7 raised to the -3 times 5, which would be -15. Awesome. Okay, but they're both negative exponents. That means we need to flip both of them. Okay, so this guy has to go downstairs. So you got 3 to the +30, and that goes away. Then this guy needs to move to the other side as well. He's going to move to the top. So now you've got 7 to the +15 on the top, and that goes away. So what you're left with on the top is just the 7 to the 15th. What you got left on the bottom is just the 3 to the 30th. You don't got any negative exponents. That means you are done. I hope that helps.